you very much. And thank you for joining us. Today, I'm going to be presenting on the combination of inspection data and ground penetrating radar. To give a little bit of background to who I am and who we are, I'm the New South Wales manager at Papworth Construction Testing Equipment. We've been in business since 2004, when founded by Frank Papworth and Reuben Barnes. And we've started out on the concrete and construction side of the industry, beginning with non-destructive testing tools, ground penetrating radar equipment, and expanding out to equipment like construction materials testing laboratory equipment and metals non-destructive testing equipment. We have a long background working in the same kind of areas you do. So I've had the chance to be trained internationally on the use of NDT and GPR tools. And we'd like to bring sort of some of that knowledge and skill set as backup for you when you choose the technologies you'll be using out in the world. Now, today, we're particularly looking at some of the different tools from Screening Eagle Technologies, whose broad range of focus includes everything from industrial testing equipment like gloss meters, but the real focus today is going to be on the equipment for concrete and construction. So that's their ground penetrating radar ranges, but it could also extend to things like Schmidt hammers, which Screening Eagle Technologies has merged with Proceq, who the original developer of the Schmidt hammer, cover meter technologies, all sorts of tools that tie back into. Now, Screening Eagle Technology is a software first supplier, so that's why we're going to be talking a lot about software today. But, and this is where I'd like everyone to be ready to unmute their microphone, maybe get involved a bit. Let's start with you. When we invited you to our webinar and you registered, we took the chance to ask you a few questions. We had a multiple choice selection of some of the challenges you face when collecting data. I also asked for the type of information you collect when you're out on site doing an inspection or collecting radar information. And I asked for any specific input you'd like. The results are in at the time when I went through this data, I was looking at information from around 80 attendees. Of those, 28% did indicate that it's that data entry challenge, having to type data in 2, 3, 4 times between handwritten notes or maybe even form-based notes on site into the report, into the output to your clients, just having to redo the same task again and again to get complete packages. We also saw that location is difficult to assign to data. Even if you have a good workflow of digital notes, they maybe don't flow through with good record to the site. The key example I'd give here is photographic data. We're all walking around with our mobile phones, recording where we've been, but it doesn't come with a close tie to location. So we'll look at how the Inspect software package can help tie our notes, our radar data, and inspection records to a position, a location. Now, the least popular one was subcontractor reports are hard to integrate, but I think that's actually a bit of a function of who's giving the answers. I've got, from what I can see of the people coming in today, a lot of you are out working to collect the information, either as GPR professionals or perhaps instead on an inspection team. But for people who are receiving your information, receiving the final outputs, the final reports, it is hard to integrate that. So this comes back to that double handling issue again. If your clients have to re-enter the information you provide them, yes, you've been of great value, you've given them that information, but if we learn to work a bit more closely together, we maybe expand beyond sharing information in unstructured data formats like a PDF report or a Word document, we'll be able to work more effectively together in the future. So that's really the world I live in. I want to see us with smooth data workflows that take real benefit of the fact that we can structure how we collect data. We can choose the way we do things to make the whole process better for everyone. So on to the next stage of the question of our survey. What do you collect out on site? I'll give you my favorite answer. I thought this was great. I sort of can imagine sort of someone laden down with 30 or 40 different machines out working endlessly to get the most information on site. But obviously that's not very detailed. So here's the actual summary. I'm going to change to a screen share now so you can have a look at the details. So now that you can see that, I've categorized it as the actual GPR measurements and scans that we take. There was a lot of mention of different kinds of defects, so I've also included that. Other forms of test data, not everything we use as a test of a concrete structure or infrastructure is necessarily going to be about finding defects or problems. It may be simple measurements that give us a condition or give us a quality or measure of if something's been done right. So other forms of test data. Location information, people might make a sketch of where they were and what they did. They may go a little beyond that and use some other way. Maybe they'll annotate drawings to indicate where they've been that they've got from their client. So we can talk a bit about that. Notes are, of course, important. You've got to describe what you were doing. Maybe if you're conducting GPR measurement work, you'll actually be choosing to describe the quality of the locates. If the job is to find 2 layers of reinforcing steel, post-tensioning tendons, and services, and you expect all of those in the area of your scan, and you didn't find it, it's important to document that. So maybe we're taking notes for that. It could also be something like an identity of an element. If we're a precast yard and we're producing structural elements, and each of them has a tracking number, that should be included in the records as well, so we know which one we're referring to with a sort of an absolute unique identifier. Unique identifiers are quite important to data. I'm not going to have too much time to go into that today, but if you've got questions or if you've got time afterwards, I'd be happy to discuss a bit about structuring data and how to sort of make it even easier to talk across between data analysis work and collection of data on site. I've also put as a separate category asset conditions and attributed data. And this is sort of bringing expert knowledge and interpretation into the process. So if we're going and out and we're scanning with our radar, we might find, we first get a visual representation, the line scan or the 3D representation of several line scans that shows a return of that energy from within the structure. With interpretation by the operator, that can become information. Here's the depth of the reinforcing steel. Here's the location of some of the things we're looking to find with our scanner. But maybe that cover depth is then compared to the expected design of the structure, some other test data like information on carbonation depths or chloride profile depths, and we start to actually be able to assess the health of a structure, the condition, and actually use our expert knowledge. That's why I highlighted that separately. I also had another response just talking a bit about topographic information, utility information, maybe survey level data collection, something you might get with a survey hardware or GNSS, GPS receivers. I've sort of not going to have too much chance to talk about that today. That's a little more in the context of equipment like the GS8000 subsurface mapping radar, or simply utility location work. Whereas the focus today, I've got a little bit more on the smaller scale concrete radar type work. But it's worth mentioning that there is different kinds and different qualities of location information. A lot of what I talk about today is going to be about locating relative positions of scan information on a drawing or on a plan. Whereas if we're going to the state of locating things within coordinate systems using surveyors as part of the process or survey equipment, it's a different kind of location information and it can be integrated differently. So just worth pointing out. So again, this is what you've told me you want to store and make use of on site. Does anyone want to provide any context, ask any questions about things? Have I explained it clearly? I'll take a second. Just unmute and jump in, and then we'll move on and we'll look at some of the specific questions that you asked me today. All right, if I may, I will continue on. So once again, just a little bit of a summary. This is not every question that was asked, but it was the ones that jumped out to me as quite important. We talked a bit about how to coordinate findings to a specific location on the structure. I'll be providing a demonstration of that. The discussion about artificial intelligence, BIM or building information modeling, which is about getting output GPR data into tools like that. I can give a few examples of that. I've got those lined up in a second. We did have questions about using technology to obtain useful information for concrete spalling repair, and secondarily specifications of existing buildings. So GPR is useful for specifications. You know, we can learn thicknesses within a certain level of accuracy, position of reinforcing steel, position of other structural elements quite effectively. But I do want to call out that if we were looking at spalling damage or that kind of defects, you might look at other tools. I'll give an example in a second. We did have a couple of questions which are more of interpretation questions. How do you see the second layer of reinforcing? How do you determine where, when the structural cage was tied together, there was lapping between reinforcing bars? I can't go into too much detail on that today. That's not the focus of this presentation, but I can maybe point out on some of the case studies I'm pulling together where there's a second layer of rebar. But I'll try and get in touch or have one of my colleagues do to the people who ask those specific questions as well. We understand that interpretation is a big part of being a competent and successful GPR user. We've always got time to talk about that. Also had a few notes just talking about crack measurement. That's probably in reference to some of the specific defect location artificial intelligence tools available in Screening Eagles Inspect. So I've got a few examples. I can show you how that works, and I can talk about the quality, how measurement comes into it, all of that as we go through that little bit of a demonstration of the tool. But firstly, let's just quickly cover spalling and delamination. I typically don't suggest radar as a very useful tool for delamination. I prefer one of the various sonic test varieties we have available, specifically ultrasonic pulse velocity is the oldest NDT around. It involves sending a pulse of sound from one side of a concrete element across to the other. And if there's something in the way, it'll slow it down. That's why we talk about velocity, speed. Quite successful for showing an effect of delamination, but that two-sided is a pain. And because delamination is such a easy to determine tool using single-sided tests, we'd probably prefer a technique like impact echo or ultrasonic pulse echo, because they can both operate from a single side. Now, with echo-based techniques, you do have to place your sensor over top of where that delamination or potential spalling has occurred. That's the biggest constraint to a echo-based technique. But I really like this tool. And just from another presentation of mine, I will point out that when you are using a pulse echo tool in particular, the interpretation is not only a positive interpretation, finding a distinct reflection from that delamination or a reduction in thickness due to a spalled section of concrete, you will sometimes also have a negative location where something you could see before, a strong, solid thickness reflection, vanishes in the spalled region. So summarizing, GPR is not my favorite tool for finding spalling and delamination. You would need a very open area. It's sort of so much so you'd probably bounce on it physically. It's so visibly popped up out of the concrete to find with radar. Whereas even a slight separation will be sensitive with a ultrasonic tool or impact echo tool. And also the interpretation of these is either positive, finding reduction in thickness, finding strong reflections at the level of the delamination, or in some cases negative, signal disappearing where signals should be available, like a thickness measurement on a slab. Continuing with our specific questions, let's look at some of the artificial intelligence functions which have improved our processes. First up is all about layer detection. So layer detection has always been part of certain kinds of assessment on subsurface. It might be about layers of soil to rock. On our infrastructure type projects, maybe the thickness of asphalt, or where we change from a pavement to the soil underneath. Now, if we're just working manually inside the GS application, this is one of the iPad applications used to control Proceq radar, we can annotate that, and that's what we can see in this picture here, just annotations showing the depth of those layers. And those annotations will export as points. They can be imported. We can make use of that data fairly easily, but it's not an automated process. It's a manual process at the level of that iPad application. Now, going forward, we've got a couple of artificial intelligence tools, and we actually also have some more conventional detection algorithms. So when we talk about an algorithm, we really just mean a set of rules. An artificial intelligence algorithm is a set of rules that's been trained by giving it positive and negative results, and it's produced a response with a certain level of reliability to detect what those training images were intended to manage. The classic example is photographic images determined to detect certain objects. You give it 1,000 pictures of telephones, 1,000 pictures of not telephones, and then you use a much bigger data set to test it, which may or may not be a telephone, see how it does, work out the percentage success rate. In terms of GPR Insights software, this is the web-based spin-off of GPR Slice being actively developed by Screen Eagle. They've built a rebar detection artificial intelligence. It's working at about 85% accuracy to pick the hyperbolas, so the positive responses in the first layer. They built this specifically as a step to assist before deterioration mapping. There's an American standard, ASTM D6087-8, the standard test method for evaluating covered concrete bridge decks, asphalt covered concrete bridge decks using ground penetrating radar. And this is based upon an amplitude map. There's an example on the left of my slide. Essentially, if you've got a reduction in signal of a reflection of rebar within a concrete element, and that concrete element may have undergone deterioration, particularly due to something like corrosion, spalling, delamination, dampness, this is a way to map that out. So the ASTM method is specific. There's also a general method available as well, based around the same process, just general deterioration mapping. This tool does mean you've got to have the location of all of your reinforcing steel locates in the first layer. And that's where the artificial intelligence comes in. And that's why it's able to locate those hyperbolas. Now, this tool is not the only thing you'd use. It's 85% accurate. So maybe a couple of locates need to be said, no, that's not correct. And the operator goes in and picks out the rest. But it's a very useful starting point. And when you're doing large data sets, hundreds and hundreds of meters of data, manual becomes almost impossibly grindy. This is where these algorithms can really step up. The other example is that asphalt layer, pavement thickness layer, soil to rock layer detection. This is a conventional algorithm. It's not an artificial intelligence, but it is showing how, again, the software tools can take our data and extract information, visible layers, visible position of reflection targets. Now, for that BIM integration, the example I've got here is actually a little bit of post-processing work on a grid scan data. So it's just conventional grid scan. A grid scan is where you take linear radar scans in two directions, a 3D representation, a slice up and down or present as a 3D signal, the strength of the reflections. An interpretation, this is where the post-processing comes in. The operator of the software has marked up the position of the reinforcing steel and a service target inside. And that sort of information can be imported and used in BIM, though the operator will need to know exactly where it is to bring that information in. It's similar to an output some clients might need of simply a drawing, because radar data needs to be at least annotated to bring that information into a drawing. Okay, so first case study I'm going to look at. If there's no questions, I'll just wait 1 second for questions.
Excuse me, just to clarify, what is the degree of accuracy? Was it 85% or at least 85%?
The 85% was was based upon the testing of that. So it's 85% accuracy on the locates. So it's not plus or minus, it's just the test had it at 85%. Okay, so onto the case study. The first case study is going to be the most common job we do with radar, marking up the ground to show where we've been and where the buried targets inside that are, reinforcing steel, post-tensioning, services, other information. I'm just going to fly past the actual procedure. But the basic output is usually marks on the ground and maybe an altered position for a planned penetration, a drill, a cut, anything like that. So we really end up at this point. So we've taken a number of scans. Maybe we've done a 2D B scan, maybe we've done some 3D scanning work with our system, and we've got marks on the ground. That's fine, but it's pretty without context. The radar data isn't linked to the marks. It's all a little bit abstract. And for certain clients, that's not quite good enough. They don't want just, here is the scan results. They want to know where it was done, the quality that the scanner believes the locates have. So was it a good place to scan? Was it easy? Or did they have some difficulty? And just a quick documentation that the scan was complete, by who, what, where, all that information. So I'm going to start within the GP application. And with the GP application, we can collect the location the data was taken. Now, this isn't to the centimeter or to the meter. This is, we were working at office building on French Street, number 32. That's the level of that georeference information. We can store photographs. We can take written or audio notes. We can also write on, tag, annotate, and mark our scans. So let's do some of those now. I'm going to start out by going into my iPad, and here is a single line scan. Now, a suspended slab with 2 layers put across on it, the position of the top level of reinforcing. But the bottom layers kind of improve the quality of my locate. I could choose to adjust. We get a bit of fuzz down here. We get a essentially signal that's passed if we're presenting the data to a client. We can clip that off. It doesn't matter. We only care about that first couple 100 millimeters of information. And that's helped improve it. I also highlight how still one of the reinforcing bars in the second layer is quite visible. So that means it's easy to say, yes, there is a second layer of rebar, but it's going to be more difficult to say the exact position. But if we are trying to pick good and safe and clear locations, we can try and inch in between top and bottom layers. There's more to it than this. And we also have access to a few other tools to improve the quality of the locates. This data was collected with a GP8000 radar. So with that one, the first thing I might do is go underneath, scan the underside of the slab. That'll mean that the top layer is now the bottom layer and vice versa. Now, if I had a machine like the GP8800, that was the unit I showed a little picture of. That one has a cross-polarization function. You can turn the entire antenna 90 degrees and scan with the orientation of the antenna sideways. And that can also improve the presentation of second layers of reinforcing steel. The other method is simply take more scans. If you do a dense grid scan or document more carefully there, that's going to be something you can do as well. So I have, well, this is not just a single scan, I actually area. This is going to a pseudo 3D or 3D presentation. With that 3D presentation, we can also project it into where the scan was taken. Joel, if you miss a corner of the office where we took the scan, and he's going to use the augmented reality functions to overlay this 3D presentation onto the ground. Now, we do need to have recorded the spot the scan was taken. That's why we've got our target down. But now we can place it in context and store a screenshot of that context. Thanks, Joel. Now, this is where data comes from, but it's actually useful for the interpretation of that data too. Talk about how we can use augmented reality for that kind of documentation. But for now, let's store that picture that shows where the data was taken. So that's the option over here. We can already see that I've got taken right in the corner. I can add to that the screenshot of that record text information. So that could be something as simple as built-in keyboard. I can plug a keyboard into my to have the right tool for the. I could also use audio notes and record that as well. And information, I can start to mark because they not only of position data that you can move between has that, if not a position 72 millimeters from the start of the scan. Export, if you want to bring this onto a drawing, say, we can also do things like work out the distance between these two. 72, 280, about 200 millimeters spacing between bars. I can even add to my comments. And if I like store a snapshot, the reason that I report, so I'm at the stage of my data collection tool writing. Additionally, we have the ability to physically draw. So I could the reflection from the bottom of the suspended be annotated. And we mentioned our second layer of rebar. Put that there. And all of this isn't just forming part of, scroll out. I've got the cloud see where all of this. So if we go to Workspace, and Workspace in a live product workflow. So everything I just completed, it's already synchronized. It's just gone through the internet. So I'll be able to log into here, and the exact same information recorded is now available for me to use. And I've saved one point of multiple entry. I might need to do a little bit of cutting and pasting, but I don't need to feed disks into devices, transfer files across. The picture I took is already stored with the scan. A little bit manual. I've still got to sit there with this open on one screen. I've already sped my workflow up considerably because it took me a minute to come across to this information rather than 5 to 10 minutes moving everything over and working out which picture comes from where, which note me, simply by taking probably another minute to document that scan. So I'm just opening it now, and we'll see all of that information that I put in the logbook immediately available within Workspace. So we have our position this scan was taken, the operation of the position of the scan. We have all of the tags have been stored in. The pictures, the particular snapshot views I wanted have been stored in that logbook and told it to save snapshot. And if I'd like, I can also review the particular position of each of the tags within that data. So those top rebar positions ready to work with. I've also, if I do want to post-process the data, I've got an export functionality in SegWi format. So I can move that data off in a raw format, which can be GPR insights, and post-process that right within the web browser if I chose to do so. So that's Workspace. It's about the ways we can use that augmented reality presentation to greater effect.
Oh, thanks. Just checking you can hear me.
I can hear you just fine, Stu.
All right, great. I have some animations, so when I say on some of the other sides to click, just give it a click when I do, but this is good for here. So yeah, just first example, I guess, as Will said, I suppose what we see happening with the GPRs we offer from Proceq is as they improve the software, they're getting to a point where the report that you do on site, so once you collect the data, is very close to what you'd be able to give to the customer as a final report without requiring post-processing. And they're also making kind of data collection and working with the data possible for almost like an entry-level user. PCTE offer a lot of training. At the beginning, we might tailor that to a project you had in mind. And then going forward, we would expand on your training as you improve with the GPR. So it's not a tool anymore that is only for experts. It's something that can be learned, especially with the way that Proceq are moving with it. So this is just an example. I have 3 case studies. The first one's just at a busy shopping center. I had a few requirements from the customer here. So they didn't want markings on the ground. They wanted things to be done quickly. They wanted a PDF the same day. They wanted a report that was understandable and results that could be provided in such a way that they could be revisited in the future without needing to rescan the area. They're basically just, there was a particular sewer line they were mostly wanting to find, but they were also just interested in everything that was inside the concrete in this area. So I just go to the next slide. Thanks, Will. And if you could click once. So, all right. Yeah, just start with the grayscale. I see it showed up on yours, but it's not showed up on the main screen yet.
Yeah,
oh, there we go. Thanks, Will. So, thanks, guys. Yeah, so in the past, when you would do a GPR scan, you as the GPR guy would get this grayscale image that you'd interpret with where the rebars would be, anything deeper, and then the bottom of the slab, and then you'd mark that on the ground. You'd spray it for them, and then you'd never show them the GPR data because nobody would understand this grayscale except for you. You'd give them markings on the ground in a final report. Next step with GPR, we went on to what's called like a migrated GPR data. So it's a heat map. Rather than having this grayscale where you've got these hyperbolas, the curves for the targets, you've got them as red dots and the red line for the bottom of the concrete slab. And that's a little bit easier to understand, but it still it doesn't combine the scan with what's happened on the ground. Oh yeah, now we've moved a step forward to what's called a superline scan. So it's a little bit of a combined image where you've got kind of the rebars running up and down on the top of the screen, and on the bottom you've got the red dots. So getting to be more understandable. And now what we've got is an area scan where we're kind of looking down at the area that we've scanned. And yeah, we're still working in this kind of spectrum type colors with blue and red. And the red lines would be all of our rebar on the top. And then we're starting to see some targets that are deeper. And with this view, we're allowed to take different slices and see what's at different depths. So we could focus on the top layer of rebar and say, okay, guys, you know, at 50 mil, we found this top layer rebar. Then we could have another picture at 100 mil for deeper targets. So we can do several screenshots, and we're starting to kind of like tie the info to what's on site in an understandable way for the client. So next one is going to be a big step forward, which is a 3D model, which is created on site without any requirement for the user to do post-processing. You do play a bit with the gain setting. There's kind of two dials you play with a bit, and that's just to get it so that the rebar are clear. I mean, it's very simple for the user. You don't need to take it home, do it overnight. You just on site move one setting up and down, and you get an image in 3D of basically everything that's going on in the concrete. And that one's nice because it so this is really like the solution now, I think, for people, because as you can see here, we can tie our scan completely onto the physical and have a report for the client that shows them their sewer drain and everything that's going on in the slab, like just mapped right on top of it. And you can bring this up in the future by going I mean, first of all, they have a document as a report of what's there, but as well, if they want to bring up this scan later, they wouldn't need to rescan. They could just go out there with the iPad and bring it up again on top of where the scan was initially done. So you'd never need to do any rescanning at this location to see what was there. I'll just add, this scan can be finished within 5 minutes. It was using the GP8100 array, so it collects 6 lines at a time for scan data. You could also use any of the Proceq GPRs. They all run off the same software to create this scan quickly and give the customer really something that's understandable and that they can have as a record forever, and that you can present to them as a PDF like straight away on site. So. All right, this is just a quick one. So we'll talk a little bit about cracking earlier. Look, I mean, GPR is going to be used here to investigate if reinforcing or lack thereof was a root cause of the crack that occurred. Historically, it's been pretty tough to correlate GPR data with the location of the cracking. It'd be meticulous, you'd have to interpret. And potentially a crack map would have been generated of the area and projected onto that area. And this maybe was done later. You know, you might have your photos from site and then your GPR data, and you're trying to kind of combine them to communicate that to the client. Yeah, GPR techs would be required to perform the scan, then prepare a report in the office to marry them together. And then you can see what's possible now if we were to approach the same job. We can do a very quick 3D scan, just a small area, and we can just overlay the data on top of the physical. So this is just the scan overlaid on the concrete So it shows you're missing bars where you had cracking. So that's something easy to give the client to say, hey, this is what happened, and documented, look back anytime you want in the future. And then I got one more case study to come. Yeah, so just detection of power conduits. Look, power conduits are a challenge because they're not always in a straight line. They may or may not be drawing current, and they're pretty weak reflectors, because they might not be very big. Congested areas on the and transitions in the construction of the structure make it even more difficult to track them. Previously GPR could collect a single line scan or small grid, but it's now possible to quickly collect a large area scan and look at things in 3D and reveal the full path of power conduits and everything else in the concrete. And again, just to make a PDF straight away for the customer. All right, so here's a 3D scan of a 3 meter by 4 meter area created in less than 5 minutes. It was 12 lines in one way and 9 lines in the other. So they only had to do about 21 lines, which doesn't take long at all. I mean, you just kind of walk along with the unit for each line you do. And we got a 3D image straight away, of the area. And then we just overlaid it on top, and, you can give something as a final report that just, I finds the power straight away there. It was sagging, it was sagging in the slab, or not sagging, but it was kind of as a curve. But yeah, we were able to pick it up pretty easily. It would normally be very difficult. Here it is in another view overlaid, and then I think I've got one more view at the end. Yeah.
Thank you so much, Stu. So what I'm going to do now is I want to fly forward a little bit. We've shown you everything you could do just in the native GP application, the tool you use to collect your data. I'm going to bring some of this information now into the inspection management platform, Inspect. So Inspect can collect form data. Now, this is something you may already be familiar with if you're using digital note-taking, where you can collect information on a form, what is this, what notes do you have, what's the measurement? That's pretty standard on digital flows. Even an Excel sheet you've customized would be something like a form. But with Inspect, we can add into that visual inspection data, images and videos. We could import the raw GPR file, so the actual measurements get saved within the cloud service for Inspect, as we're duplicating what we took with our GP application. We can bring in other forms of NDT data, whether native Screening Eagle Technologies tools, or maybe exported information from third-party products. We can bring in other documentation. Maybe you've got some reports back from your laboratory, carbonation, chloride depth, things like that. Pull those in. We also have some functions that take advantage of the AI development work being done by Screening Eagle with the defect mapping, which we've started out with the crack mapping functionality. And I'll show that, and also the ability to take a LiDAR scan. So back to the iPad, we're going to be doing a demonstration. I'm going to get the only information up. That might be enough. If all I need is, I can style view. So we can start where we are. We can take a photo, or we can load in information. So I can pull up a plan drawing I've already got available, 2D data. Maybe we don't have, we could do a 3D LiDAR scan as our So this functionality is enabled, has the LiDAR scanning sensor available. Application, we're now taking quite detailed what we took our GPR scan before, and he's going to give us a 3D world to place that's in addition to did inside of our GPR. So we've got one version of the map. Let's store some need to position my different templates here, because I said, you may be familiar to store my GPR data coded purple. I'll give it a compare from our GP application showed earlier with augmented reality. That scan data. So now anyone can come back and export with the full data. Now, we talked about how sometimes information numbers, so I could do something like, and my cover depth was, I'm just going to fly through a cover measurement. Then my depth measurements are reasonable. Then I can check the depthing back into my Inspect application, a cover depth. Hold on a second. And that is structure good to go. If I want to produce a report, I've got a report creation. Now, what I can do is GPR template. So I can go across to my customization tools, go to my to place the information about bar spacing or affecting the data I previously worked on. New field, a numerical field. Or if I'd be able to instead pre-existing multiple subfield of spacing between rebar. So that particular radar device as a default option to the new ones as well. So here we're going to get the same spacing between rebar option, and then that'll be available for both of our form template. And we can see that so that's different kinds of information we can collect and a sample of our GPR data. I'd like to thank you all for coming along to see some case studies and to talk a bit about if there's anything I can do for you. Now we're beyond the hour of the presentation. I'd be very happy to do so. Thank you very much for your time.